Welcome to the Big Picture Podcast. My name is Carolyn Wright. I'm your co-host for today.
And I'm John Wright, your other co-host.
Today, we have the honor of interviewing Dr. Anoop Sondhi, orthodontist as well as inventor of Sondhi Rapid Set adhesive resin that has revolutionized the practice of orthodontics. In the olden days, orthodontic braces were brackets welded to bands that were cemented to each tooth.
Ouch!
With Dr. Sondhi's approach and keen use of chemistry, the braces are now instead bonded to the outer surface of each tooth. Our dear friend of ours and a mentor. Welcome, Dr. Sondhi.
It's a pleasure to be with you.
Thank you so much for joining us. Dr. Sondhi, what was your original interest? How did you get into orthodontry?
Oh, a couple of things. My father had a dear friend who was an orthodontist, and he was a very, very cool guy, and I wanted to be like him, and that got me interested in the field, and the interest never really abated. I like the science, and I like the art portion of it. There is a certain visual element to what we do as orthodontists. I like very much being able to shape things for young people. I like to be able to correct things and help older patients who want that correction. And it is a combination of all those things that draws me to do what I do.
You find it a rewarding profession.
It is an extremely rewarding profession.
One thing that's caught my attention about what you do is that you played a role in the development of an adhesive, not just the adhesive, but the procedure for braces that don't wrap as bands around each tooth, but braces that attach to the surface.
Yes, there has been a change over time where we used to put what were fondly referred to as railroad tracks, which were the metal bands that went around the teeth. That has since been replaced by braces that are attached directly to the outside surfaces of the teeth. It's the way that you attach the brackets to the teeth that is referred to as bonding. Now, this is bonding as in a mechanical bond. It's not what in chemistry you might think of as a covalent bond, for example.
Covalent, not ionic, not metallic, but
it's a physical bond.
Okay.
The reason I tell you that is that you can bond the braces to the tooth with a procedure called direct bonding, which is literally to put a resin on the bracket and then place it on the tooth. The version that I developed was called indirect bonding, whereby I can set the braces exactly the way I want them to end up on a patient's teeth on a model. And then we developed a procedure to transfer that through a transfer tray from the model onto the patient's teeth. That made the process much more accurate and much more efficient. But we had to develop a resin that was also designed for that purpose. The working time required is very different when you're trying to put 14 brackets on at the same time as opposed to just one.
So you have all those brackets going on to the patient's teeth, like lower teeth.
Yes, sir.
All at one time.
That is correct.
When you say indirect, that means it's attached to the tooth indirectly?
No, it is transferred to the tooth indirectly.
So you attach it
onto a model.
Yes. And then from that, it's going to fit the shape of that patient's teeth and hand and glove.
Correct.
Okay.
And then the resin that is used to attach those braces to the teeth had to have properties that were consistent with that procedure, and that is the resin that we developed and that I
You mean like the timing, it should set within so many seconds?
The timing, the viscosity, it needed to flow a little more easily into some crevices. So it was a combination of the timing and the viscosity.
Once it's on the teeth, is there opportunity to tweak it, the positions a little bit? Or is it just work so well on the model that it's pretty much on?
There is no need for having to tweak anything. On the off chance that a bracket were to be applied incorrectly, it is not a difficult matter to remove the bracket and repeat the procedure.
Can you talk about how it actually sticks?
Yes. When you look at the enamel surface on a tooth, it looks like a really smooth surface, but it is actually, at a microscopic level, a series of enameled rods.
Rods facing out or vertical? Or
vertical.
up?
They are. If you are looking at the front surface of the tooth, you're looking at the top of the rods.
Oh, so if you had a bunch of straws, plastic straws, and you're holding them in your hand, and then you look through those straws like through a window.
That's a very good analogy.
So they're coming out. They're coming
at you.
Oh,
now in between those straws, with the visual that you just gave me, or in between the enameled rods, is some further enamel material, but it is of a different degree of calcification than the enamel that's inside the rods.
The calcification, you mean the amount of calcium hydroxyapatite
Correct.
That's in there?
Correct. Because bone is primarily calcium phosphate and so forth. Mm-hmm. So because of the difference in the calcium content of the enamel rod, the enamel that's in the matrix between the rods.
Yeah, that holds the rods together.
Also correct.
Yeah.
If you then apply a 37% phosphoric acid solution.
Phosphoric acid?
Yes, sir. Just for a few seconds, it will etch the enamel surface. And because the difference in the calcium content of the enamel rods and the matrix material, it will etch it unevenly.
So, wait, let me guess. In between the rods, it gets etched more.
You are correct, sir.
Yeah.
So now we have all these rods with the little divots, if you will, between them, which creates enough roughness, and it's at roughness at a very, very high microscopic level, that the resin then fills those in and creates the mechanical bond to hold the braces onto the tooth.
Mechanical bond. So
That's correct.
So Velcro, like Velcro's mechanical. You've got all this surface area, all these little hooks holding on to the nooks and crannies. So there's a mechanical.
There is a certain similarity. There is, unlike Velcro, though, there are no moving parts.
But once it's adhered, I'm envisioning a glue that's just filling all these nooks and crannies, so it has all this surface area of contact.
Also correct.
But is that strong enough to hold it against the forces needed to push the teeth?
It is strong enough not only to withstand the forces required to move teeth, but this is strong enough to let the patient then function in a day-to-day basis. They eat, and you frequently eat stuff we even tell them not to eat.
There's a lot of force the jaw can apply.
And the resin is strong enough to tolerate that. There has to be a point where the resin can fail. And that can happen if a patient really abuses it. For example, if somebody starts crunching on ice cubes, it's like crunching on rocks. And the reason that happens is, frankly, the day comes that we have to remove the braces, so we need to be able to make it fail anyway.
I could live the rest of my life with these on.
Right.
Make them transparent. But okay, yeah, so they have to come off.
And that happens by exceeding the bond strength that we expect it to have during day-to-day activity.
You take a pair of pliers and pull?
We do indeed. We don't actually pull. There's a special pair of pliers that gets between the bracket and the tooth and breaks that enamel bond.
It's a solid.
That's correct.
A brittle solid.
Also correct.
And do you whack it a little bit? And then
Nope.
A gentle squeeze on a bracket, and it just gently releases from the tooth.
If I can explain it this way, the weakest part of the bond is its ability to tolerate a shear force.
It's the sideways.
Right. So we have an instrument that gets under the bracket and provides that shear force.
Remarkable.
Very gently.
It doesn't hurt.
When was this developed?
The resin that I developed was developed in 1999.
So would you classify yourself as a chemist?
No, I'm an orthodontist. I worked with chemists with the R&D department of 3M. 3M is a company that has extensive experience with different types of resins and glues.
Adhesive, those are the people who make Post-its.
They make everything from Post-its to a number of products that you and I use that have some sort of adhesive component.
Scotch tape.
So they had the chemists in their R&D department who understood the properties that I needed in the clinic and were able to work with me to develop that resin.
Did you contact them or did they contact you?
I had been doing some consulting work for them, and so the conversation came up almost organically as a part of my work with them.
You talked, Dr. Sondhi, a bit about how the tooth is prepared to receive the bracket, but is there anything special that actually happens to the bracket material to prepare it to be attached to the tooth? In other words, is it rubbed against an abrasive or something to make it more coarse?
No, the bracket at the time of manufacture will have one of two things in it. If it's a metal bracket, it will have a mesh back to it. So the mesh, by definition, provides the mechanical bond required for it to adhere. If you see the newer clear braces, those are generally ceramic braces. They're literally made with porcelain. And in order for them to attach to the resin, there is a prime layer of silane that is put on the inside of the ceramic bracket. So the bond between the bracket and the resin, if it's a metal bracket, is a mechanical one. But if it is a ceramic bracket, it's actually a chemical bond because the methyl methacrylate, which is the foundation of the dental resin, bonds to the silane that is painted onto the underside of the bracket.
Having worn braces just a few years ago in my past, I remember those painful spacers. You're telling me people don't have to wear those anymore?
That is correct.
Wow. And people are wearing braces for 2 and 3 years still, or is it less?
It is way less than it used to be. Everything is so much more significantly efficient. A patient that might have been in braces for, shall we say, 2 years in the early years of my career, when we were still using bands, that patient would today be in braces for maybe 12, tops 14 months.
I would say better living through chemistry. Yeah, sorry.
New orthodontists that are in school learning the procedures, so is the indirect bonding method used almost exclusively now, or is it one of 2 or 3 different procedures that an orthodontist has in his or her toolkit?
It varies a little bit, but most of the educational programs will teach both direct and indirect bonding. The doctors then tend to choose which they prefer when they enter practice. That said, there has been a steady increase in the number of people who want to use the indirect bonding procedure simply because it is more efficient and more accurate. It does require doing some extra laboratory work, and so some people don't want to do that. But for reasons that have to do with the advent of digital technology, where you can now literally simulate in a digital setup what the outcome of your alignment with braces will be, there is a steady move towards incorporating indirect bonding because it just works better with digital technology. We are also now just seeing the advent of 3D printing. There's only one company so far that has started this, but others will move in this direction because they are going to make it possible to literally 3D print your own braces in your own office.
Dr. Sondhi, I know this technique is being used here in the United States pretty extensively. What about abroad? What about other countries?
All over the world. So when I first developed this, I wrote an article that was published in the American Journal of Orthodontics, introducing everybody to the procedure and the resin that I had developed. The second thing is, of course, as your work becomes known, then other people want to learn by inviting you to speak at conferences, teach continuing education courses at universities and so forth. And over the last 20-some years, I have taught courses in 64 different countries. So it's been all over the world. The third avenue, of course, is through the videos. Now, everything is accessible. Our videos are available on YouTube and so forth. So people learn these procedures in different ways. But yes, it is something that is used in a rather significant number of orthodontic offices around the world.
So back in the 1990s, when you started using this technique, did you find any resistance from your colleagues?
Oh, certainly. We had to prove it. I had to publish case reports. We did studies to demonstrate the efficacy of the material, the bond strength of the material. So we wrote several scientific articles. basically, we also got lucky in that some people around the world, especially some orthodontic programs in the United States and also in Germany, used this material for a number of studies that were published. So it's over time, its efficacy got established. But yes, there's always resistance at the beginning because people are used to doing things a certain way and they want to have a really persuasive reason before they will change.
But about how many years would you estimate it was, would you say that reluctance lasted? Was it like a year, 5 years?
Oh, it was closer to 3 to 4 years before we overcame that.
Mm. And it was a lot of effort, evidence, testimonies.
All of the above. It was primarily publications in journals. You have to publish verifiable data in peer-reviewed journals. And then I had to lecture and show the effectiveness in treatment.
Yep.
Orthodontics is a highly visual specialty. What orthodontists want more than anything else is to see your stuff on a screen so they can analyze it. And they want to see consistently well-treated cases in order to believe what you're telling them.
You talked about 3D printing earlier. Was that 3D printing of the braces themselves?
That's just starting. It is not a well-established procedure yet. As I think I mentioned, there's only one company that has been touting that they have the ability to give you the software whereby you can design what type of braces you want to put on the patient's teeth and print them in your own office.
What material is being printed?
Oh, primarily the same acrylic that's used for printing.
Acrylic?
Correct.
Okay. And that has a tensile strength to...
So they claim.
Yeah.
We don't know that yet.
Okay.
Hence the resistance to change.
Hence the resistance to change, right.
Do you have other passions in your life aside from orthodontry?
Yes, I do. I happen to be a pilot. I am very interested in aviation, and I have been flying for 36 years now, and I would say have been a very serious pilot. I haven't pursued it just as a weekend hobby. I have a commercial pilot's license. I'm certified to fly jets, and I have an airline captain's rating.
Wow. What advice would you have for today's student?
You know, it is frequently said that if you find work that is enjoyable to you, then you won't feel like you're working very hard for the rest of your life. And that is true. I think it is critically important that one be passionate about what you are doing, because otherwise it gets harder and harder to get up in the morning and convince yourself to leave home and go to work. So you have to have a passion for what you are doing, but the reality of life being what it is, you have to be able to monetize that passion and make a living and provide for family and do all of those things. But there is a particularly good reason to believe that if your passion for something is profound enough, then the monetizing becomes easy. And I say that simply because I have seen young people who chose a profession primarily because of their ability to monetize. And by the time they were, shall we say, 40 years old, that is no longer enough satisfaction. So I think it would be unwise to approach life with rose-tinted glasses. But if you had to choose between the two, I'd stick with the passion. Because monetizing a passion is a heck of a lot easier than being able to monetize that and have no passion left to go for it.
Dr. Sondhi, thank you so much for joining us here at the Big Picture Podcast.
It's been my pleasure.
Definitely learn some things. Oh, that's great.
We have the recording. Our theme music by Zach Jeffrey. Musical flourishes by Patrick Wright on jazz guitar, Scott Pizzera on bass, and Carrington Clinton on drums. Production assistance from Greg Simmons and C-Pro Music. Our special thanks to Anoop Sondhi, D.D.S., inventor of the trademarked Sondhi Rapid Set Indirect Bonding System, used by orthodontists worldwide. For show notes and more, please visit conceptualscience.com. A note of appreciation to all instructors using Conceptual Academy. Thank you for your support. And to the hardworking student, our thanks to you as well for your learning efforts, which we see as the path to making this world a better place. Good chemistry to you.